11.2 Areas of regular polygons. Remember, a regular polygon is a polygon, all the sides are the same length, all the angles are congruent. So we're going to start off with the most basic regular polygon, an equilateral triangle. And if you remember an equilateral triangle, if we're trying to find the area, we're going to first remember that what the measure of this angle is. So if you took 180, and since these angles are all the same, divided it by 3, you get it's a 60-degree angle. So if I want to find the area of this polygon, I need to figure out its altitude. And if this is a 60-degree angle, and an altitude is measured at a right angle, this is a 30-degree angle. So from here, notice we have a 30, 60, 90 triangle. So for a side length S on this triangle here, this triangle that we broke apart, this length would be 1/2 S. And the altitude, since it's a 30, 60, 90 triangle, our special right triangles, I can multiply this short side by the square root of 3. So this would be 1/2 S times the square root of 3. So that would be the height of this triangle for any given side length S. Therefore, we can come up with a formula for the area of an equilateral triangle. Okay, so the area of any triangle is 1/2 the base times the height. And in this case, our base is S, and the height is 1/2 S times the square root of 3. Now with a little simplifying, 1/2 times 1/2 is going to be 1/4. S times S is going to be an S squared, and we still have the square root of 3. So this is the cleaned up version of the formula. Find the area of an equilateral triangle side length 10 centimeters. We can use our formula, 1/4 the side length squared times the square root of 3. And now all we have to do is put in 10. So 1/4 10 squared times the square root of 3. Order of operations, say square first, I get 100. 100 times 1/4 is 25. 25 times the square root of 3 centimeters would be an exact answer, and you can approximate that by doing the square root of 3. Oops, gotta hit 3 first, now hit the square root. Times it by 25. That's approximately 43.3 centimeters. Oh, boy, do I have that wrong. It's an area. My answer has to be centimeters squared. We're measuring the inside area. All right, the area of a regular polygon. I can find the area of any regular polygon by taking a polygon. Any regular polygon could be inscribed in a circle, and we call the center of the circle the center of the polygon. And we can split the polygon into triangles that are all congruent to each other. So I split it up into, in this case, 6 triangles. I can find the area of this polygon by saying the area of the one triangle times 6. Now, the blue line is what we call a radius, because it's a radius of the circle that's inscribed the polygon. And from, like, the height of one of these little triangles is called an apothem. Okay, so from the center directly to the side, the distance from the center to the side is called the apothem. So here we have kind of the formula for a regular polygon derived out. Area of one of those triangles times the number of triangles. Well, how do you find the area of one of the triangles? If you look back up here, it's the side length of your polygon times your apothem, or 1/2 the side length times your apothem. 1/2 apothem times side length times the number of sides is going to tell you how many triangles there are. Well, if we take the side length and multiply it by the number of sides, that's how you find perimeter. So we can rewrite these. Side length times the number of sides, that's the same thing as perimeter. And we get this condensed down formula, 1/2 the apothem times the perimeter. Okay, so the capital A represents the area, the little a represents the apothem. A regular octagon is inscribed in a circle with radius of 4 units. So I already got a picture started drawn out here, but the radius is 4 units. Find the perimeter and area of the octagon. Now, to do this, there's quite a few steps. There's a few things I need to figure out. I need to figure out the perimeter, and I need to figure out what the apothem is so that I can find the area. So, looking at this, I know this is 4, the radius, so I pulled this triangle out. I pull it out so that we can look at it a little bit bigger. I know this is 4, and this is a right angle. And what we're going to be doing is we're going to be using some right triangle trigonometry to figure out the apothem and our side length. I'm going to call this x. We need to figure out x so that we can figure out the perimeter. Okay, so in order to do this, we need to figure out what this angle is right here. Okay, so if you think about it, this is an octagon. So how many triangles do we have? Right, each side is going to correspond with one triangle. So if I want to know this angle, since there's 8 of those triangles, it would be 360 divided by 8. But I want to know not this big angle, I want to know this angle here, which is going to be double those. I'm not going to take 316 divided by 8. I'm going to divide it by double 8, 16. There's going to be 16 of these little right triangles that make up this regular octagon. So 360 divided by 16, 360 divided by 16, 22.5. Okay. Try to move this over here. So this is how I'm figuring out that angle right there. Okay, the total 360 degrees divided by the number of triangles. And now that I know that that's a 22.5 degree angle, I can use my SOHCAHTOA to find A and X. Okay, so to find A, this is here's my reference angle, my opposite side, my hypotenuse, and my adjacent side. So I need to use the hypotenuse and adjacent. So remember, SOHCAHTOA, adjacent and hypotenuse is going to be our cosine. So the cosine of 22.5 is going to equal adjacent to the hypotenuse. So I can put that over 1 and cross multiply. So I need to take the cosine of that, make sure your calculator's in degrees, and then I'm going to multiply it by 4, and I get A is 3.695, so I'm around that 3.70. And now to find x is the opposite side. I'm going to use the 4 because that's an exact measurement from what I know. The sine of 22.5. Sine is opposite over hypotenuse, so x over 4. Write it as a proportion, cross multiply and divide. And times 4. X equals 1.53. Okay, so if x equals 1.53, the side length would be double that, which is, you see how I didn't round anything? I'm keeping it exact as possible. This whole side length then is 3.06. So my perimeter is going to be that number times the number of sides. Right? Perimeter is the total distance around. I have 8 of those sides, so I'm going to take that answer and multiply it by 8. And I get perimeter equals 24.49. Notice I haven't rounded any of these. I keep using all those decimal places. And now that I know my perimeter, that's one of the answers we're looking for. To find my area, it's going to be 1/2 the apothem times the perimeter. The apothem is A. This is my apothem. Okay, so if that's my apothem, I'm going to take 3.70 times 24.49. Times 1/2. Same thing as dividing by 2. So I get my area is approximately, I had to round it, 45.31. And my units, they just say units, so I have to put units squared. I should really put units on here. Okay, so notice, taking away from this, you cannot do one of these problems without showing a lot of work. Okay, it really helps to draw pictures, but you need to do those steps. Okay, so I know this might take a little bit more study time to really understand what's going on here. We're going to do some more examples because it takes a while to get this stuff. So here I'm not being as nice and I'm not drawing a picture, giving you a picture yet. The bottom of the glass is a rectangular dodecagon. It's got 12 sides, a dodecagon, with a side length of 1.2 centimeters and a radius of 2.3. So I'm going to start drawing my dodecagon almost a little bit, but I'm going to focus in on this triangle. Okay, I'm going to figure out the area of that. And I know the side length is 1.2 and the radius is 2.3. I still would like to find my apothem. And notice my perimeter should be a pretty easy find. My perimeter equals the 1.2, the side length, times the number of sides, 12. This is almost like 12 times 12, or 144, but we have one decimal place. So I know my perimeter is going to be 14.4 centimeters. Now all I got to do is find my apothem. So notice that this problem, because they gave us the side length makes it a lot easier. Some of these problems are going to be tough because you got to do a lot of finding. Some of them aren't as bad, and they all look about the same. So don't judge the book by its cover, right? Just keep working. So to find the apothem now, I'm going to find this angle. So if there's 12 sides, that means there's 12 of these big triangles. That means there's 24 of these right triangles. So I'm going to take 360 and divide it by 24 to figure out this angle. So that angle is 15 degrees. So now, this is a right triangle. I know this is 2.3 as well. I could take 1.2 and divide it in half and get 0.6. And now I just need to find my apothem. Okay, so I'm using my SOHCAHTOA again. And now I have some choices of what I can do because I know more than just one side. I'm going to use cosine. The cosine of 15 degrees is going to equal my adjacent side, the apothem I'm looking for, over the hypotenuse, which is 2.3. And cross multiplying and dividing, I'm going to be taking cosine 15, multiplying it by 2.3, and I get my apothem is 2.22. Okay, that'd be like centimeters. Now that I know my apothem and my perimeter, 1/2 2.22 times 14.4. So multiplying by half, I'm going to divide it by 2 instead, times 14.4. I get my answer of my area, 15.995. I'm going to call that 16.0. Centimeters squared. Now, notice how I put the 0.0 in. That shows that, when I'm rounding, it showed that I rounded to the nearest tenth. Where if I just put 16, I could have been rounding to the nearest whole number. Take a 15.6 and rounded it up to 16. So that putting in an extra 0 at the end is important for rounded answers. Shows where you rounded to. Alright, so I know this video is getting long, I apologize. But here's a trick for making these things go faster. There's a special thing that happens with regular hexagon, and we're going to see regular hexagons a lot. So if we can come up with a little formula, that's great. So if you notice, there's 6 of these triangles. So if I took 360 and divide it by 6 to figure out what one of these angles is, 360 divided by 6 is 60. And turns out that this is an equilateral triangle. Now we already know a formula for an equilateral triangle. So the measure of a central angle is 60 degrees, which makes the measure of an interior angle. The interior angle is 120 degrees. You can figure that out by 10 minus 2 times 180. Right, to figure out the measure of all the angles, but then divide it by n. And if you put 6 in there, you're going to get out 120. And so this whole angle is 120 degrees, which means one of these angles is 60. So that's why we have an equilateral triangle. So what is a formula for a regular hexagon? We can use the area of one of the equilateral triangles, 1/4 the side length squared times the square root of 3, that formula for an equilateral triangle. But how many triangles do we have? Well, it's a hexagon, it's got 6 sides, so I have to multiply this by 6. 6 times 1/4. Going to reduce that down a little bit and get 3/2 the side length squared times the square root of 3. So this is a very, very helpful formula. Make sure you have that one written down. Here's just another example. And for the sake of time, it's already a 20-minute video. I will skip it. You can watch your other examples again if you still have questions, but there's 2 things we'd have to find. We'd have to find the apothem and this side length, right? Once you find those 2 things, once you know this side length, you should be able to find the perimeter, and once you know the apothem, it's just your 1/2 the apothem times the perimeter. Okay, so just remember, if you're putting this in your calculator, usually try to include parentheses around it. Here's another example. Notice this one's going to be easier because you already know your apothem. All you have to do is find this side length. You only have to find one of these things. From here, you should be able to find your perimeter and calculate the area. There's your homework assignment. Toodaloo, kangaroo.